Okay, so here's the simulator that we're going to use to make calculations for different distances that the fallen object is going to go into the ground. Okay, and if you look, what's going on here? We have everything we need. We have at the top potential energy equals mgh, which we knew, and that's at a height of, everyone sees that? What height? That's h, good. Okay, and then at the bottom, when it hits the ground, potential energy becomes 0, good. Who was that? Debbie, good. And kinetic energy is 1/2 mv squared, right. And the velocity, if we solve for velocity, is the square root of 2gh. Okay, so we're going to enter in a few parameters. I'm just going to put in about 5 kilograms, 2 meters high, about my height. The velocity is about 6¼ meters per second. But the important number is the kinetic energy is about 100 joules. Okay? So if we take that number and we look to see, we want to find out is how far into the ground that would go if there was an impact force of, in this case, 20 newtons. Okay? So 5 meters times 20 newtons is 100 joules. So that ties out. Now what we want to see is if the force changes, okay, what happens to the depth? Or if the depth changes, what happens to the force? So if we change the depth, okay, from 5 meters, if we say it's going to go 10 meters into the ground, who thinks the force is going to be greater? Show of hands. Okay, that's about all of you. About almost everybody. Who thinks the force is going to be less if it goes 10 feet into the ground? 2 people. Okay. So let's see what happens. We'll make it 10. And then enter. The force went down. So the 2 people were right. That doesn't make any sense to me, does it? No. What we're saying is that the depth is twice as deep and the force is half. Okay. Can anybody try to explain that? Okay. What about the 2 people that raised their hand and said it was going to be less? Why did you think it was going to be less? Tom, you answer. So you're saying that the product has to be the same. And what does it always have to equal? 100 joules. Did everybody get that? That's excellent. He's right. Right. We looked over here, okay, and we determined that the kinetic energy is going to be 100 joules, and that's our constant. And we know that to reduce that force, to reduce the speed to 0, to slow it down, we need a force of 10 newtons to work for 10 meters, and the object will stop. Very good. Okay, so let's wrap up, and we'll talk about summarizing all this.